On August 12, 2026, the sky above Earth is going to do something it hasn't done in over 100 years. In the same 24-hour window, the sun will vanish in the middle of the day. The night sky will catch fire with meteors. And deep inside our own star, scientists are about to get a look at something that has puzzled them for over a century. NASA has been tracking this date for over a decade, but here's the question nobody's fully answered yet. Why does this keep happening in cycles? And what does the next one tell us? To understand why this is rare, you have to understand what a total solar eclipse actually is. The moon is, on average, 400 times smaller than the sun, but it's also about 400 times closer to Earth. That's not a coincidence of convenience, it's basically a cosmic accident of scale. It means that from Earth, the moon and sun appear almost exactly the same size in the sky. When the moon lines up perfectly between the sun and Earth, it blocks the sun's light completely. For a few precious minutes, day turns to night. NASA calls this alignment syzygy. It's happened before, but not layered on top of two other rare events on the same day. And that raises a bigger question. How often does something like this actually happen? The answer: almost never. Total solar eclipses happen roughly once every 18 months somewhere on Earth, but they rarely fall on the exact same date as a major meteor shower peak. This year, they do. Because while the moon is busy blocking the sun, Earth is also plowing directly through a trail of ancient debris left behind by comet Swift-Tuttle, a comet that last passed near Earth back in 1992 and won't return again until 2126. That debris is what creates the Perseid meteor shower. But here's what's strange. Scientists still don't fully agree on exactly how much debris is out there this year, or how intense the peak will actually be. Some models predict 100 meteors an hour, others predict double that. Why the uncertainty? That's where it gets interesting. If stuff like this keeps you up at night wondering about the universe, subscribe now, because we're about to get to the part almost nobody talks about. The uncertainty comes down to debris density. A trail of comet dust isn't uniform, it's clumped, and Earth's exact path through it shifts slightly every year. That's the meteor mystery, mostly solved. But there's a second mystery happening at the exact same moment, and this one has stumped physicists for over 150 years. During totality, when the moon fully blocks the sun's blinding surface, something becomes visible that we can never normally see. The sun's corona. It's the sun's outer atmosphere. And here's the part that should not make sense. The surface of the sun is about 10,000 degrees Fahrenheit. But the corona, sitting further away from the sun's heat source, is over 1,000,000 degrees. Hotter, not cooler. Physicists call this the coronal heating problem, and it remains one of the biggest unsolved questions in solar physics. Nobody has fully explained why moving away from a heat source makes something hotter. There are theories. NASA's Parker Solar Probe, the fastest human-made object ever built, has been flying directly through the corona since 2018 to try to solve this. Leading theories point to something called nanoflares, millions of tiny magnetic explosions happening every second across the sun's surface, invisible from Earth, possibly injecting enough energy to superheat the corona. Another theory points to Alfvén waves, magnetic ripples traveling along the sun's magnetic field lines. But here's the honest truth. Even NASA's own scientists will tell you this still isn't fully solved. And on August 12th, ground-based telescopes and citizen observers across the eclipse path will be capturing corona data that could add a new piece to a 150-year-old puzzle. Which brings up the real question. When was the last time this much cosmic activity lined up on one single day? Astronomers have combed historical records, and triple alignments like this, a total eclipse, a major meteor shower peak, and rare planetary visibility all in the same 24 to 48-hour window, are documented perhaps only a handful of times in the last several hundred years, and never with modern instruments capable of studying all three simultaneously. That's what makes August 12, 2026 different. For the first time, we have satellites, solar probes, and global observation networks ready and pointed at the sky at the exact right moment. So the next question is simple. After this, when do we get another shot at this? The next total solar eclipse crossing similar territory won't happen again for decades. The next Perseid peak this strong won't repeat for years, and a corona observation window this well instrumented may not come again until the 2030s. Which means August 12th isn't just rare, it's a once-in-a-generation research opportunity happening in plain sight, above your own backyard. If you're in the path of totality, across the Arctic, Greenland, Iceland, and northern Spain, you'll see the sky go fully dark for a few minutes. If you're anywhere in North America, you likely won't see totality, but the Perseids will still be firing at their peak that same night, visible to the naked eye, no equipment required. And in the pre-dawn hours, 6 planets will line up across the eastern sky. One day, 3 cosmic events colliding, a 150-year-old solar mystery getting fresh data, and a sky pattern that won't repeat for decades. August 12th isn't science fiction. It's already been confirmed, tracked, and mapped by NASA and observatories around the world. Mark your calendar, look up, and if this is the kind of thing that makes you want to understand the universe a little better, subscribe, because we've got more of these mysteries coming.